Yeah, good afternoon. We are back with our classes on alcohol, phenols and ethers. Okay, we did the preparation of alcohols and we studied the preparation of alcohols first by hydration of alkene, or that is acid catalyzed reactions of alkenes, where water would be added to alkene. That if it is an unsymmetrical alkene, it would follow what rule? Markovnikov's rule. We studied the mechanism of hydration of alkene. So till now you have studied three mechanisms, that is SN1 mechanism, SN2 mechanism and hydration of alkene. Make sure to write them on a sheet of paper because we have two more mechanisms. Out of these five mechanisms, whether it is CBSE board or state board, one of the mechanism will be 100% there for 3 marks because it consists of how many steps? 3 steps. When we did hydration of alkene, the first step was protonation of alkene, second step was attack of electrophile on the carbocation, and third was deprotonation. So first thing, there was protonation to form the carbocation, second was attack of the electrophile on the carbocation to form an additional product, and then there was deprotonation of the compound to give back alcohols to us. Second method which we studied in the preparation of alcohols. See, I am writing separately methods, you should know. First was hydration of alkene, or you can remember it as hydration of alkene and hydroboration of alkene. These are the two important methods for formation of alkene. Then we studied reduction of aldehydes, ketones, carboxylic acid and esters. Okay, the second method was reduction of aldehydes. Reduction of aldehydes will give us primary alcohol. Reduction of ketone will give us secondary alcohols. Reduction of an alkene is basically not possible. Reduction of tertiary alcohol or reduction of carboxylic acid, tertiary alcohol I shouldn't say. Basically I should say reduction of carboxylic acid also gives me primary alcohol, and reduction of esters we studied. First, how do we form an ester? When a carboxylic acid reacts with alcohol, it forms an ester, and when you reduce an ester, you get two alcohols or a mixture of alcohols. Now, today we have to study. These were the methods. You can check from your textbook. These were the methods which we have studied for the preparation of alcohol. Now we will study preparation of alcohols using what? Grignard's reagent. So today we will study the last method. What is the method? Numbering method. Fourth. How fourth? Yeah, hydration of alkene, hydroboration, reduction of aldehyde, reduction of ketone, reduction of carboxylic acid, reduction of ester. Sixth method. Okay. So now fourth, if you say like that, the fourth method is preparation of alcohol using what reagent? Grignard's reagent. Using Grignard's reagent. Okay, we need to study the preparation of alcohol using Grignard's reagent. The speciality of Grignard's reagent is called as what compound? An organometallic compound. It is called as an organometallic compound because here you have the carbon atom directly being attached to the metal atom. I have been telling this multiple times. It is called as an organometallic compound because here the metal atom is directly attached to the carbon atom. Now please understand very clearly. First thing, when Grignard's reagent, I am writing RMgX, when RMgX reacts with formaldehyde. Formaldehyde is what? HCHO, methanol. It gives what? Primary alcohol. Okay, now again I am writing the second part. When RMgX reacts with any other aldehyde other than HCHO. HCHO is what? Formaldehyde. We get what alcohol? Secondary alcohol. Okay, this has to be learned. And now the third part. What is the third part? When RMgX reacts with ketone, it gives what alcohol? Tertiary alcohol. This is a very important CET question. If I want to get from Grignard's reagent primary alcohol, I should always react it with what? Aldehyde. Which aldehyde? Formaldehyde or methanol. If I use any other aldehyde other than formaldehyde, I will get what alcohol? Secondary alcohol. And if I use a ketone, I will get what alcohol? Tertiary alcohol. So now we will first write the first equation or A. First I will write the general equation and then we will substitute. So we have got RMgX plus HC double bond O, or I will write this here so that it is easier for us to add, and H. Correct? Now you know this C double bond O, the double bond will break. The oxygen atom will have all the electrons of the pi bond. So this becomes what charge? Negative charge. And this becomes what charge? Positive charge. You know metals always are what charge? Positive charge. So this metal will go and add up here. So now this becomes the main carbon center. This carbon atom becomes the main center. So I have C, I have an H, and I have to satisfy, there is one more H, and I need to satisfy its valency. So this R will come there. So you will have an R, then you have what? O, and then it continues as OMgX. This is an intermediate compound, and this intermediate compound is called as an adduct. Okay, what is it called as? An adduct or an intermediate compound. This immediately gets hydrolyzed. Hydrolyzed means what gets added? Water gets added. So how does water get added? An H is added here and an OH is added here. Water is H2O, there is an H added and an OH added. So now I am writing it here. So what will I get? C, H, R, OH plus what I get? Mg, OH and X. This is what alcohol? It's a primary alcohol because it ends with what? R, CH2, OH. Is it clear? Now we are supposed to substitute this R as CH3 and do the same equation. Please write. CH3 as CH3MgX plus H, C double bond O and H. I will get what? C. You will have an H. You will have CH3. You will have, an H, and you will have OMgX. This is an additional compound and it is called as what? An adduct. Break the bond here, add an H here and add an OH here. This is called as what? Hydrolysis of the additional compound. You will get a product as what? C, H, CH3, OH. This is what alcohol? Ethanol. Okay? CH3, CH2, OH. This is called as what? Ethanol. And what do you get along with it? Mg, OH and Cl. So the first equation here, whenever I want a primary alcohol from Grignard's reagent, I should always react it with what? Formaldehyde. If I use any other alcohol. So now we will write the second equation or the B part of it to get what? Secondary alcohol. See here, the general part of the equation. If I take RMgX and I react it with, I am writing this as R dash CHO. R dash CHO is any other aldehyde. It may be C2H5, maybe C3H7 or any other aldehyde. Then again I will get what compound? See, I will write again like this. C double bond O and an H. This bond shifts. This oxygen gets a negative charge. This gets a positive charge. So I get what? This carbon becomes my main carbon. You have O, you have Mg, you have X, you have R, you have R dash and an H. Correct? See, you have an R dash, you have an R, you have one H of this. Now this again is what compound? An additional compound and would be called as an adduct. It undergoes what? Hydrolysis. So you add an H, you add an OH. This becomes what? C, R, H, R dash and OH. Plus you get what? Mg, OH and X. Correct? So this compound, just see, it has two alkyl groups attached to the carbon to which OH is attached. This is what alcohol? Secondary alcohol. So if I use any other aldehyde other than formaldehyde, then I get what? I will get secondary alcohol. Now let us substitute our R's with alkyl group. I will now substitute my R with alkyl group and write the same reaction. So we will see what kind of an alcohol we get. Let us suppose I write CH3 MgX plus I take CH3 C double bond O and H. The double bond shifts. This becomes negative charge and this is what charge? Positive charge. So I get an adduct which is C, which has an H, which has O, MgX and you have what? CH3 and CH3. See, when you are writing an original reaction, this X also you can substitute. Most of the time we will use what? CH3 MgBr. So I will write this X as what? Br. What compound? An additional compound. So called as what? An adduct. This breaks down as H and OH. You get what? You get a compound like this. You have C, CH3, CH3, H and OH plus what you get? Mg, OH and Br. This is a carbon which has two alkyl groups attached to it. So called as what alcohol? Secondary alcohol. Are you back name? 1, 2, 3. So called as what? Propane to all. Understood till here? Now we will go to our third logic. What was our third logic? Our third logic was when I use any other carbon, any other ketone, then I get what? Tertiary alcohol. So the general equation for that, let us write RMgX plus what is there? Ketone. Ketone means I will write R C double bond O. Let us write this as R dash and R dash. Okay, this is how it is. Now again what happens? The double bond oxygen or the double bond shifts. Oxygen gets a negative charge and carbon gets a positive charge. So you will get what? This carbon becomes a center carbon. You will get C, O, MgX and you have an R of Grignard's reagent and you have 2 R dash from ketone. This is an additional compound and is called as what? An adduct. This on hydrolysis gives what? R dash and OH. So I will write MgX and OH. Look at this carbon. This carbon basically has 3 alkyl groups attached to the OH, attached to the carbon which has got the OH group. So it is called as what alcohol? Tertiary alcohol. Very important method, comes for 3 marks in board. How do we prepare alcohols using Grignard's reagent? So if I want primary alcohol, I should use formaldehyde. If I want secondary alcohol, I should use any other aldehyde other than formaldehyde. And if I want a tertiary alcohol, I should always use what? Ketones. So now substituting the alkyl groups in ketones. This was a general equation. Now let us make an alcohol. Generally, we will substitute it with the first alkyl group. So we will get what? CH3, MgBr plus we will write what? CH3, C double bond O, CH3. This shifts, it gets a negative charge, this carbon gets a positive charge. This carbon now becomes my main center. I have one side CH3. I have the other side also CH3, this side also CH3, and I have OMgBr. Break, this is an H, this is an OH here. So I get what? I get C, CH3, 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 OH, plus I get what? Mg, Br, and OH. Name of the compound, it is a tertiary alcohol, commonly called as tertiary butyl alcohol, or in IUPAC it will be called as what? 2-methyl propane to all. 2-methyl propane to all, or tertiary butyl alcohol. So this ends up our methods of preparation of aliphatic alcohols. Okay? So, what are the different methods of preparation of aliphatic alcohol? You should always remember, because when you write in CET, you should know which are the different methods by which you can make alcohol. So, summing up, please write hydration of alkene, hydroboration of alkene. You should know this. Hydration of alkene, hydroboration of alkene, reduction of aldehyde, ketone, carboxylic acid and ester. And then the last, using what reagent? Grignard's reagent. This is the method of preparation of aliphatic alcohols. First one, hydration of alkene, hydroboration of alkene, reduction of aldehyde, ketones, carboxylic acid and ester, and the last using what? Grignard's reagent. Clear? In Grignard's reagent, if I use formaldehyde, what do I get? Primary alcohol. Any other aldehyde? Secondary alcohol. If I use ketone, I get what alcohol? Tertiary alcohol. Clear? Now we will study phenol, methods of preparation of phenol. Then after that we will study reactions of alcohol, reactions of phenol. And in the end we will study ethers. So first, phenol, also called as what acid? Carbolic acid. Now, structure of functional group. Structure of functional group in phenol. Structure of functional group in phenol. Do you remember structure of functional group in aliphatic alcohols? What did we say? We said in aliphatic alcohols, the sp3 hybridized carbon overlaps with the sp3 hybridized orbital of oxygen to form what bond? Sigma bond. We also studied that the bond angle of ROH 96 and this was what? 100. Not sorry, mega not 142 picometer. 96 and 142 picometer. This was the structure of what? Aliphatic alcohol. Now we need to know the structure of functional group in phenol. What is phenol? C6H5OH. How do we write this? It is an aromatic compound and it basically has what carbon? You have I'll write here a carbon and there is an O and H. This oxygen has how many lone pair electrons? 2 lone pair electrons. Please draw this and then I'll make you write. In phenol, please write. In phenol, the OH group, please look here. The OH group is attached to the carbon. This carbon is what hybridized? It's a double bond. So it is what hybridized? sp2 hybridized. In phenol, the carbon to which OH is attached, is sp2 hybridized. Second point, the carbon-oxygen bond length. The carbon-oxygen bond length is 136 picometer. What was the carbon-oxygen bond length? 142 picometer. So 142 now 146 sir? 142. Here it is how much? 136 picometer. This is due, or why this is due we are telling, it is slightly less than the aliphatic alcohols. This is due to the partial double bond character. This is due to the partial double bond character acquired by carbon due to resonance. Partial double carbon due to resonance. First point clear? We all know, see, I'll explain here. You will get what? A double bond here. You have a C, you have an O, you have an H. When you transfer the lone pair electron, what happens? This gets a double bond and this bond breaks. This is, isn't it? This is how you show resonance. So you get what? That CO bond becomes what in the next case? In the next case structure, I get what character? Double bond character. So due to the partial double bond character, the bond length decreases. Right, second point. Due to the sp2 hybridized state of carbon to which oxygen is attached. Due to the sp2 hybridized state of carbon to which oxygen is attached. So let us just check both the things. First thing, please look here. In an aliphatic alcohol, there is an sp3 hybridized carbon overlapping with an sp3 hybridized oxygen atom to form what bond? Sigma bond. The bond angle is slightly less than 109 degree 28 minutes due to lone pair repulsion. The oxygen-hydrogen bond length is 96 picometer, whereas the carbon-oxygen bond length is 142 picometer. Hybridization sp3. When it comes to phenol, the carbon to which OH is attached is what hybridized? sp2 hybridized. The oxygen-hydrogen bond, please write there. The oxygen-hydrogen bond is, okay. We spoke about the carbon-oxygen bond, not the oxygen-hydrogen bond. So the carbon-oxygen bond is how much picometer? 136 picometer, which is less than 142 picometer. This is because of partial double bond character acquired due to resonance and the sp2 hybridized carbon. Now let's write methods of preparation of phenol. Let us write methods of preparation of phenol. Write first method from haloarenes. From haloarenes. If you would have really studied the chapter correctly, you would remember that when phenols react with sodium hydroxide, it forms sodium phenoxide or sodium phenate, which on hydrolysis or acidic hydrolysis gives phenol, right? Chlorobenzene is fused with NaOH. Chlorobenzene is fused with NaOH at 623 Kelvin and 320 atmospheric pressure and 320 atmospheric pressure to obtain sodium phenoxide. To obtain sodium phenoxide, which on acidification gives phenol. Which on acidification gives phenol. Okay, so let us write. See, whenever in an organic chemistry paper they tell you to write equations, first you should write the subject content in words and then only you should write the equation. If you just write the equation in any of your board exam, whether CBSE or state, you will not get full marks. Okay, so first thing what? We take chlorobenzene. This is our chlorobenzene. It reacts with what? NaOH. Whereon at what temperature? 623 Kelvin. And at what atmospheric pressure? 320 atmospheric pressure. See, you will have what? This goes and adds up. What is removed? HCl is removed. So you get what? C6H5ONa plus HCl. Okay, this C6H5ONa, when it reacts with HCl, it forms what? C6H5OH. It gives what? Phenol. What is the compound this is? This is called as sodium phenate. This is called as sodium phenate and this is called as what? Phenols. Okay. So first thing, take chlorobenzene, react it with NaOH at 623 Kelvin at 320 atmospheric pressure to get sodium phenate, which on acidification will give what? You can remove this HCl and write right over the arrow HCl, which on acidification gives phenol. Now for the second method of preparation of phenol, we will use the second method of preparation of phenol. I am writing it here. First was what? From haloarenes. Haloarenes react with sodium hydroxide. Now the next method is using what? Benzene sulfonic acid. So from benzene sulfonic acid. From benzene sulfonic acid. If first of all I should know what is benzene sulfonic acid. Always understand when sulfonic acid group andre SO3H group. This is called as what? Sulfonic acid group. So if I have to talk about benzene sulfonic acid, it means the name of the compound should be what? C6H5SO3H. This is called as what? Benzene sulfonic acid. Now write first benzene sulfonic acid formed by reaction of benzene with oleum. Benzene sulfonic acid formed by reaction of benzene with oleum gets converted to sodium phenoxide on heating with molten NaOH. On heating with molten NaOH, which on acidification gives phenol. Which on acidification gives phenol. Okay. See, this is what? Benzene sulfonic acid. So what we have written? This benzene sulfonic acid is obtained when benzene reacts with oleum. What is oleum? What is oleum? Sulfuric acid, when it is obtained, is always obtained in form of oleum. Oleum is what? H2S2O7. This is called as oleum. When benzene reacts with oleum, it forms what? Benzene sulfonic acid. This benzene sulfonic acid, when it reacts with NaOH, this is the first compound, and then it gets acidified with HCl to give what? Phenol. Understood how we wrote 1 and 2? You cannot write above the arrow and below the arrow, because if you write above the arrow and below the arrow and I do not know which one to use first, the entire equation will go wrong. So always write first and second. So first what we do? We use NaOH. What it forms? Actually it forms what? C6H5ONA. When you react it with HCl, it forms what? C6H5OH. So this is what we have written. So now understand. What did I say? Benzene sulfonic acid is formed when benzene reacts with oleum. This benzene sulfonic acid, when it is treated with NaOH, it forms sodium phenate. This sodium phenate, when it is acidified, it gives what? Phenol. So clear the reaction? The reaction is benzene sulfonic acid, when it reacts with NaOH, followed by hydrolysis or followed by acidified hydrolysis or followed by acidified reaction with HCl, gives you what? Phenol. Now the third method of preparation. I am writing here, the third method of preparation is what? From benzene diazonium chloride. First was what? From halogenes, then from benzene sulfonic acid, and next is what? Benzene diazonium chloride. Please write from diazonium salt. Or if you want, you can write it as D if you are getting confused. From diazonium salt, HBD. Please write diazonium salts are hydrolyzed to phenols. Diazonium salts are hydrolyzed to phenols by warming them with water or by treating with dilute acid. By warming them with water or by treating with dilute acid. Now let us understand. Again, I will write here third method of preparation. From what salt? From diazo. Diazo means N2. Diazonium salt. So what are diazonium salt? This is my diazonium salt. C6H5N2Cl. N2 How did we start? We took aniline, isn't it? We took aniline and we reacted it with what? NaNO2 and HCl. This is called what? HNO2. What was the temperature? 0 to 5 degrees centigrade. When I react with aniline with NaNO2 and HCl, I will get what? Benzene diazonium chloride. This when it is warmed with water. When you warm this reaction with water, water can also be written as what? HOH. See, this H and this Cl will be removed. Nitrogen also will be removed. OH will come and add here. So I will get what? C6H5OH plus N2 plus HCl. This is what kind of a reaction? An elimination reaction where nitrogen is removed from the reaction mixture. So the third method of preparation of phenol is from diazonium salt. What was the first method? From haloarenes. Take haloarenes, react them with sodium hydroxide, it forms sodium phenate. React it with acid, it gives you it gives you phenol. Second was from benzene sulfonic acid. Take benzene, react it with oleum, you get benzene sulfonic acid. React it with NaOH and HCl to get phenol. Third, diazonium salt. When they are warmed with water, they give you what? Phenol. This is a very important method for all CBSE students because it helps in conversion of diazonium salt into phenol, or it helps in conversion of what? Aniline into phenol. Convert aniline to diazonium chloride, and from diazonium chloride warm it with water to get phenol. Now the next method of preparation, please write, very important method of preparation. Anytime in exam this is always seen. This is from cumene. This is the manufacture of phenol. This is the last method we studied. So this is what? Manufacture of phenol. Manufacture means what? Prepared in large scale in industry. Please write, manufacture of phenol or cumene, from cumene. So the next method, the fourth method is from cumene. It bande barutte kannu muchkondu gnapaka itkoli. This is very important. Okay, and in CET they ask you what is cumene. Cumene is what? It is isopropyl benzene. Cumene is what? Cumene is isopropyl benzene. See, there may be a lot of confusion with organic chemistry. Whenever you sit to study organic chemistry, make sure you make these small abbreviation kind of thing. You should know when I say preparation of phenol means HPDC. HPDC means haloarenes, NaOH. Benzene sulfonic acid, NaOH, HCl. Diazonium salt, water. Cumene, we will learn. Same way as we said. Again I'll ask you, methods of preparation of aliphatic alcohols. What was it? Hydration of alkene. Correct? Next was what? Hydrogenation of alkene. Reduction of aldehyde, ketone, carboxylic acid, esters. Then something else? What was it? Grignard's reagent. So this is the method of preparation of alcohol. Same way, what are the method of preparation of phenols? From haloarenes, from benzene sulfonic acid, from diazonium salt, and last from cumene. If you know this, anywhere if a question comes, you should be able to answer as to how we prepare. And if you think towards the end, one day I will sit and read, you will not make chochova, it will be much worse. That is why when we were all small and we did our MSCs in organic chemistry, we told it every day, organic chemistry badi bewafa, raat ko padhe, din ko safa. Whatever you read in the night, it just vaporizes and volatiles. What if you study haloarenes, alcohol gets forgotten. If you study alcohols, Haloarenes, aldehyde ketones gets forgotten. So you are supposed to develop methods to know short forms. Pada equations baribeku. If you think I will just read it like this and do, it is next to impossible to learn. What Nandita ma'am is teaching, all those things if you understand once, you can write something on your own. But here, if you don't know, you cannot bluff. I am going very slow so that you understand and you remember. If you don't, then Bhagwan Mahavir. That's all. So now isopropyl benzene. First let us understand the structure of isopropyl benzene. See, CH3, CH2, CH3 is what? Isopropane. Yes, remove one H, add one benzene. So this becomes what? Isopropyl benzene. This isopropyl benzene only is called as what? Cumene. Okay, now write. Cumene is oxidized in presence of air to form cumene hydroperoxide, which is converted to phenol and acetone, by treating with dilute acid. So what is cumene? Cumene is isopropyl benzene. It needs to be oxidized. If not, but it is a very simple, nice, pyara sa reaction. Look here, you have this as an isopropyl benzene. When you react it with oxygen, each other oxygen bರುತ್ತೆ. ಈ CH bond ಮಧ್ಯದಲ್ಲಿ hydrogen ತಳ್ಳಿಬಿಟ್ಟು oxygen ಮಧ್ಯದಲ್ಲಿ ಬರುತ್ತೆ. So what you will get? You will get a compound COOH. You have CH3 and you have CH3. Because there is O2, it is called what peroxide? Hydroperoxide. Any O2, H2O2, you know it is a peroxide. So it is called as what? Cumene hydroperoxide. This cumene hydroperoxide, when it is treated in presence of acid and hydrolyzed, okay, it forms what? Within the building. What it forms? CH3, CO, CH3. Plus what is left? Phenol. So you get what? C6H5OH plus CH3, C double bond O, CH3. This is called as acetone or propane to one, and this is what? Phenol. This is generally used for the preparation of phenol, and the byproduct obtained by this method is called as what? Acetone. Acetone also, you know, is used as what? Nail polish remover. Clear? So this is a very, very important reaction. This will 100% come if you are writing a test on chapter of alcohol, phenols and ether. It is generally used in the manufacture of phenol, or manufacture of phenol in large scale is done by cumene process. Cumene is isopropyl benzene. This one reacts with oxygen. It forms cumene hydroperoxide, which on acidification will give you what? Phenol and acetone. Please write CET anta baridi for competitive exams. Phenol is obtained from coal tar. Phenol is obtained from coal tar. You know what is coal tar? All of you have seen? You haven't seen coal tar? To tar the road, one black colored liquid. Okay, so please write coal tar. Next point, coal tar is subjected to fractional distillation. The fraction distills between 170 to 230 degrees centigrade. The fraction distills between 170 to 230 degrees centigrade and is called as the middle oil fraction. Sorry. And is called as the middle oil fraction, which contains phenol, naphthalene, cresol, pyridine or pyridine and other impurities. Okay, write the next point. The middle oil fraction is cooled. So what gets separated when the middle oil fraction is cooled? Naphthalene crystallizes out. So naphthalene is removed because from the middle oil fraction, when it is cooled, naphthalene gets solidified and it crystallizes out. Then write, it is treated with sulfuric acid to remove pyridine. It is treated with sulfuric acid to remove pyridine and then treated with NaOH. Sodium phenate is formed. Sodium phenate is formed, which reacts with carbon dioxide to form phenol. Which reacts with carbon dioxide to form phenol, which is separated from the mixture by fractional distillation. Which is separated from the mixture by fractional distillation. Okay, so basically remember, there are two methods of obtaining phenol in a large scale. One, by QEing process, and second, it is obtained from coal tar. Coal tar, when it is fractionally distilled, you get a fraction between 170 to 230 degrees centigrade. That is called as the middle oil fraction, which contains phenol, naphthalene, pyridine, cresol and some impurities. When it is cooled, naphthalene crystallizes out. Sulfuric acid is acidic, so it removes the basic impurity of pyridine. What else is left? You have cresols, phenols left. These cresols and phenols, when they are treated with NaOH, phenol forms sodium phenate, which when basically reacts with carbon dioxide gives phenol. Phenol is always obtained from the middle oil fraction of coal tar. Okay, this is only for CET. This finishes all the methods of preparation of alcohol and phenol. You are supposed to do as homework. Please write. Page number 323, example 11.2. Page number 323. I don't know. Okay, 323 or 331, example 11.2. And also in my book 325, 11.4 and 11.5. Okay, 11.4 and 11.5. Kindly do the equations and we will study this in the next class. Okay, thank you.